Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem 2780, minimum index of a valid split. This problem is based out of a very important array algorithm, that is Boyer-Moore voting algorithm. This algorithm is commonly used to figure out the majority element in an array. Element that is maybe more than 50%, more than 1/3. And this problem is already quite famous, majority element. If you have not solved this problem, I would recommend you to watch this video or to figure out the explanation on this Boyer-Moore voting algorithm, or try it by your own. I'm also going to attach the link to this video in the description below. Now let's come to our problem statement. This question has been marked as medium. I will directly explain the problem statement to you with the help of an example. Here, what is the given part? Given part is we are given an array of integer, and they are saying that in this array of integer there is one integer, let's say that is x. That integer is dominating the array. It means that is present more than 50% of the times. Let's say the array size is 10. It means there should be one element which is appearing more than 5 times, at least 6 times, and that is our majority element, that is x. So x is present there, which is dominant, that is more than half of the elements in array. Okay, this is given part, and what operation they are expecting. Let's say whatever is the given array to us, we have to split this array into two sections, split at index I, such that when we are splitting at index I, let's say indices are something like this, 0, 1, 2, 3, 4, 5, and we have decided to split at index 4. So it will be something like this. From elements from 0 to I will be on the left side, and elements from I plus 1 to n minus 1, those elements will be on the right side. They are expecting us so that we split this array, keeping in mind that the majority element remain the majority element for the left portion as well as for the right portion, right? So let's say in this case, if we have a look on the first example, here in this given array, 2 is the majority element because the size is 4 and 2 is coming 3 times and 3 is more than 4 by 2, 50% of the size. So 2 is a majority element. If I just split it like this, in this case the left portion does not have the majority element as a majority one. If I just split it like this, the right portion have 2 as a majority element, but the left portion does not have 2 as a majority element. 2 is coming 50%, not more than 50%. But if I try to split it after index 2, here on the left side 2 is a majority element, on the right side 2 is a majority element. It means this split is valid. In that case, what we have to return is return the minimum possible index of that split, earliest split that you can make, such that left portion and the right portion have the same element as a majority element. This is our problem statement. And here, if the split is not possible, in that case we can return -1 directly. Return the minimum index of a valid split. If no split exists, return -1. So this is our problem statement. And let's say if I just have a look on the second example, this is my second example. Here, what is the majority element? First of all, I should know what is the majority element. After that I will decide how I can make a split. Here in this case I can let me directly tell you that okay, 1 is a majority element because the problem statement is not so big. 1, 1, 2, 3, 4, 5, 6 times it is coming, and the total number of elements in the array are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Size is 10, and 6 times 1 is appearing in the array, that is more than 50%, more than 5. So majority element is 1 in this array, and now we have to make a split. Here this split looks valid. If I just split after index 4, left side it is 3 elements. 3 elements out of 5, majority 1. And on the right side 3 elements out of 5, it is also majority 1. If I try to make a split after index 3, in that case on the left side 1 is not a majority element, so this is not a valid split. And in this case 4 is the first index where I am getting the majority element, also the majority element on the left portion, right portion. So it is a valid split. Minimum split index if possible, otherwise return -1. Okay, so how do we do this? First of all, I should know what is the majority element. Let me capture this array. This array looks good. Let's explore our approach on this example. First of all, I am thinking that I should know the majority element. What is the majority element? Any element X which is appearing more than 50% of the times. It means any element that is coming more than n by 2 times. And how do we figure out that? Just capturing the frequency. If you are capturing the frequency, then you might require an extra space, and in that case there is one algorithm, Boyer-Moore voting algorithm, that helps us to obtain the majority element in one iteration, order of n time, and order of 1 space. This is explained in detail in this video. If you want to have a look, just check the description section below. Otherwise, let's move ahead. Majority element we can find using Boyer-Moore voting algorithm. Why? Because it's a better one. It does not allow us to take more space. And why we are not solving this using hash table? It's very simple. You can do it by your own. Just take a hash table, capturing the frequency. How we can capture the frequency? Just take a hash map, and after that iterate over all the keys. Then you will definitely get the majority element by comparing the value with the number of nums array. But in the majority element, what we do usually is we consider the current element as the candidate to our majority element. Let's say the majority element is 2, and along with that I also maintain a counter. Counter is 1, and we do the iteration from left to right. In this case, we achieve it in order of n time, order of n space. And this majority element, this Boyer-Moore voting algorithm, what this does is this provides us the candidate. When we are done with our iteration, we will be having one candidate that might be the majority element or might not be. But in the constraints, I can see the nums has exactly one dominant element, only one majority element. It means the problem inputs are valid, so there is no need to validate whether the candidate is actually the majority element or not. So whatever the candidate I will get, that will definitely be the majority element. So initially the majority element is 2, count is 1. When the current element is equal to the majority element, just increment the count, otherwise decrement the count. Next item is 1, decrement the count. In this case, whenever the count becomes 0, update the count with 1 and update the majority element with the current element, that is 1. So 1 is coming 1 time. Now 1 is coming 0 time at 3. And now update the majority element, 3, count is 1. Here 1. The count is becoming 0, and you have to update the majority element. 1 is coming 1 time. Now 1 is coming 2 time at this. 1 is coming 3 time at this. 1 is coming 2 time at this. 1 is coming 3 time at this. 1 is coming 2 time at this. 1 is coming 3 time at this. So this is my majority element. This is actually this algorithm gives me the candidate, that this can be the candidate. But here, as we are already given that the majority element definitely exists, so this candidate itself is a majority element. So now we have the majority element, that my majority element is 1. And what is the count of majority element? Just do the iteration again. Do the iteration again in the array and just capture the count. And the count is 6 in this case. 1, 2, 3, 4, 5, 6. Count is 6, majority element is 1. And in this case, we have to do the split. Now I have to make a split. Let's see how we are going to do that. let's say I am making a split. I can make split after index I. So definitely the split options will go from 0 to n minus 1, less than n minus 1. So I can split after 0 index, after n minus 2 index. This is the range. So let's say I have split at 0. What I should know is the majority element, that is 1. It should be the majority element on the left side, as well as it is the majority element on the right side. Now in this case, 1 is majority element on the right side, that is true. But on the left side, it is not the majority element. So what you should do is, you should know the frequency of the left frequency and right frequency. And the left frequency should be more than the half of the size of the left array. Let's say I have got the left frequency and the right frequency of the majority element. Frequency of majority element on the left portion and the right portion. What is the size of the left portion? From 0 to I, that is I only. I plus 1, because index is starting from 0. So I plus 1 is the size of the left array. If the majority element actually is the majority element, then the left frequency should be greater than I plus 1 divided by 2. So this condition should be valid if 1 is the majority element on the left side. If 1 is the majority element on the right side, then the last item is n minus 1. First item is I plus 1. How many items are there? N minus 1 minus I plus 1 plus 1. From index I to j, we have j minus I plus 1 items. If I just solve it, n minus 1 minus I minus 1 plus 1 cancels out n minus 1 minus I. So the right frequency should be greater than size of the right array, n minus 1 minus I divided by 2. So these two conditions should fulfill. So what I can do is, I can start from the left portion and keep on going in the right side, and whenever if this condition meet successfully, I can directly return index, because at this index there is a valid split, right? And in this case, you might wonder how I'm going to capture the left frequency and the right frequency. See, the left frequency, you are already doing iteration. If you are already doing iteration, you can capture the frequency in some count variable. You know the left frequency. How do you get the right frequency? You know the actual count, complete count. So right frequency is always the total number of count of the majority element minus the left frequency, right? So the left frequency, just capture it while doing the iteration. So this validation, this checking the valid split, I can do in order of n time, right? So ultimately, finding the majority element. Finding the majority element is my step 1, majority element. Second one is left frequency, right frequency, and making a split at I. Both are order of n operation. So ultimately the time taken by this operation is order of n. And what about the space? Are we using any extra space? I don't think we are using. So the space complexity is order of 1 time. And this is because of the Boyer-Moore voting algorithm, like majority element finding algorithm. Now let's have a look on the code. Here what I have done is, step 1 is finding the majority element using Moore voting algorithm. Majority element, let's say the first item is majority element and counter is 1. And if starting next onwards, if the element is same as majority element, increment the count, otherwise decrement the count. If at any moment count is 0, it means that current element is 50% on that portion. So discard that. Update the majority element. In this case, after this step, at step 2, I am having majority element with me. Now capture the count. Capture the count of this majority element. See, there is no need to check this condition, because it's already given that nums has already one dominating element. Now you have the count of the majority element and you need to capture the valid split. Valid split means the left count and the right count have enough frequency. So the left count into 2 should be greater than I plus 1. Or this is the same that we have discussed, I plus 1 divided by 2 and minus 1 minus I divided by 2. And this is order of n time. And this is our whole algorithm using Boyer-Moore-Werting algorithm, capturing the count and then maintaining split, just doing iteration. Let me test our sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thanks for watching. In case you get any doubt, you can comment down below. Bye bye guys.